Surveying instruments are tools used to make precise measurements of the Earth's surface, including distances, angles, and elevations, to create maps and establish property boundaries. These instruments are crucial for various applications like construction, engineering, and land management. Key surveying instruments and their uses: measuring tapes and chains, used to measure distances, with chains being made up of metal links and tapes available in various materials like steel, fiberglass, or alloy. Compass, used to determine the direction or bearing of a line relative to magnetic north. Theodolite, measures both horizontal and vertical angles with a telescope and is often used for traversing and triangulation. Total station, an electronic instrument that combines the functions of a theodolite and electronic distance meter, EDM, allowing for precise angle and distance measurements. GPS, global positioning system, utilizes satellite signals to determine positions and is used for mapping and establishing control points. Levels, automatic, digital, used to establish horizontal elevations and determine differences in elevation between points. Plane table, a drawing board mounted on a tripod used for field sketching and mapping. Tripod, a three-legged stand used to support various surveying instruments like theodolites and total stations. Leveling staff, a graduated rod used with a level to determine elevation differences. Ranging rods, used as visual aids for sighting and aligning points during surveying. Plumb bob, a pointed weight suspended from a string used to establish a vertical line. Measuring wheels, used to measure long distances by counting wheel revolutions. Classification on the basis of purpose I, Amonate Survey 2, Control Survey. Control Survey uses geodetic methods to establish widely spaced vertical and horizontal control points. 3. Geological Survey. Geological survey is used to determine the structure and arrangement of rock strata. Generally, it enables to know the composition of the Earth. 4. Military or defense survey is carried out to map places of military and strategic importance. 4. Archaeological survey is carried out to discover and map ancient/relics of antiquity. Classification based on instrument used. I. Chain/tape survey. This is the simple method of taking the linear measurement using a chain or tape with no angular measurements made. 2. Compass survey. Here horizontal angular measurements are made using magnetic compass with the linear measurements made using the chain or tape. 3. Plane table survey. This is a quick survey carried out in the field with the measurements and drawings made at the same time using a plane table. 4. Leveling. This is the measurement and mapping of the relative heights of points on the Earth's surface, showing them in maps, plane and charts as vertical sections or with conventional symbols. 5. Theodolite survey. Theodolite survey takes vertical and horizontal angles in order to establish controls. Classification based on the method used. 1. Triangulation survey. In order to make the survey manageable, the area to be surveyed is first covered with series of triangles. Lines are first run round the perimeter of the plot, then the details fixed in relation to the established lines. This process is called triangulation. The triangle is preferred as it is the only shape that can completely over an irregularly shaped area with minimum space left. 2. Traverse survey. If the bearing and distance of a place of a known point is known, it is possible to establish the position of that point on the ground. From this point, the bearing and distances of other surrounding points may be established. In the process, positions of points linked with lines linking them emerge. The traversing is the process of establishing these lines, is called traversing, while the connecting lines joining two points on the ground. Joining two while bearing and distance is known as traverse. A traverse station is each of the points of the traverse, while the traverse leg is the straight line between consecutive stations. Traverses may either be open or closed. 1. Closed traverse. When a series of connected lines forms a closed circuit, i.e. when the finishing point coincides with the starting point of a survey, it is called as a closed traverse. Here Abdia represents a closed traverse. Fig 2.1a. Fig 2.1a. Closed traverse is suitable for the survey of boundaries of ponds, forests, etc. 2. Open traverse. When a sequence of connected lines extends along a general direction and does not return to the starting point, it is known as open traverse or unclosed traverse. Here Abt represents an open traverse. Fig 2.2b. Fig 2.2b. Open traverse is suitable for the survey of roads, rivers, etc.